All right, so for example A, all you have to do is distribute into your parentheses. You're taking a monomial, 3x, distributing it into your parentheses. When you distribute, the rule you follow is you multiply your coefficients and you add your exponents. So my coefficients here are 3, and then there's a 1 in front of this x. So we multiply those and get 3. And this is x to the first, and this is x to the first. So we add our exponents. So we get 3x squared plus 15x. Distributive property. All right, you're just distributing with variables now. So we go to example B. Shoop and shoop. Again, we're multiplying our coefficients, adding our exponents. So we're multiplying 6 times 4, which is 24. And then we're adding, it's an x to the first and an x squared. So it'll be 24x to the third. And then last one, 6x times positive 1, it's a positive 6x. In example C, I snuck in, you have to be careful, I snuck in a z term. So when we multiply, we don't want to mix our x and z's together or leave one of them out. So we're still going to multiply our coefficients. So 4 times 4 is 16. And how you want to write it is just x z to the third. All right, both of the x and the z needs to stay in your first term. So we multiply, we did that. Now we had to distribute to our second term. That's minus 8x squared. Distribute to our third term. That's plus 28x. So you have a few homework problems like this where all you're doing, if you see something in front of the parentheses, you're just distributing. Simple as that. What we're going to learn how to do now with these other ones, we're multiplying. In example A, we're going to use what's called the box method to multiply a binomial by another binomial. So how you do the box method, it's super nifty. First you draw a box. And then inside that box you draw 4 smaller boxes. So boom and boom. You can just recycle it. What you do is on the top of the box, in each one of these kind of columns, you put whatever in your parentheses. So I'm going to put an x above this column and then a positive 5 above my second column. On the side of my box, I'm going to put an x and a positive 4. Since our initial operation was multiplication, we are going to multiply into each one of these tiny squares. So we're going to take x times x, that's x squared, so that goes in this box. We're going to take 5 times x, we get out 5x, that goes in that box. We take x times 4, put it in this box, we get 4x, and then we get 4 times 5 in our last box, and that's 20. So, looking at this diagonal in our box, when we're doing the box method, on some diagonals you'll have like terms. Like this is a like term, so we can combine these. All right. So we take 5x plus 4x, that's 9x. So I like doing this so I can kind of group my like terms together, but we're combining like terms. Fine. Like terms. You may see some people write it. I write out everything that's in the box, like an x squared. Then I write plus 5x plus 4x plus 20. So then we see here that we have like terms, just like we have in the diagonal of our box. So when we combine like terms, we have x squared plus 9x plus 20, and then that's our final answer. It's a trinomial of the second degree with the leading coefficient of 1. So for our second example, we're going to do the same thing. Set up a box, 4 smaller squares on the inside. I'm going to do it a little off-center. X and then a positive 3 on the top. You always have to take the sign of the number that's with it. So it's a plus 3. It's a plus 3 up here. So down here will be a minus 4. So x and minus 4. Again, you multiply into your box. X times x is x squared. This is 3x. Negative 4x. I'm multiplying. And then this is negative 12. And again, like terms on our diagonal. So I can combine those. I can say my final answer is x squared. Negative 4x plus 3x is negative 1x minus 12. If you think you can do number C on your own, I encourage you to go ahead and try it. Otherwise, just follow along with me. Making another box. Yeah. Sure. We're taking, now instead of just an x term, now we have a coefficient in front of it, so it's 2x. We have a minus 1. Then we have an x and a 5 along the side. So multiplying, we have 2x squared minus 1x, 10x, then minus 5. Again, along our diagonal, we have 2 like terms. They're both x terms, so we can combine them. 2x squared minus 9x minus 5. Oop, it should be plus 9x, because 10x minus 1x is plus 9x. So that's if we're multiplying a binomial, so 2 terms by 2 terms. Does anybody have a guess of what we have to do if we have a binomial multiplied by a trinomial? Yeah, we're just going to add an extra kind of either row or column. So if I always like to keep whatever is like the first parenthesis on the top of my box, the second one on the side of my box. It doesn't matter where you put them in the box. It could go on the top or the side. Doesn't matter. I just try to stay consistent. So if I know I have 2 terms in my first parentheses, I know I have to have 2 columns. If I have 3 terms in my second parentheses, I know I have to have 3 rows. So I will write this as, make your box. This is x and plus 5. And then the sides of the box, we have an x squared plus 3x plus 2. Like terms, this is an x to the third. This is 5 times x squared, that's 5x squared. X times 3x, 3x squared. 5 times 3x, that's 15x. This is 2x, and this is 10. And now our diagonals also, they still have like terms. We have like terms along this diagonal and along this diagonal. So you have to remember, you go from multiplying into your box to when you're combining like terms, you're adding. the number in your top corner will always be kind of your first term. The number in your bottom corner will always kind of be the caboose of your polynomial, or it should, most of the time, it's a constant. So this would be x to the third. Now we combine our first diagonal. 5x squared plus 3x squared is a positive 8x squared. 15x plus 2x is a positive 17x. And then we have plus 10. There's a lot of ways that you can do this multiplying. This is kind of, I think, the best method, because I think it keeps all your work nice and tidy in one spot, and there's less opportunities for mistakes because it's kind of everything is, each part is sectioned off, and it's easy. If you do mess up on something, it's easy to find it because everything has its own box inside of the box. So E, we do the same thing. A 2 by 3. We have a 2x and a positive 2. We have x squared minus x plus 6. So multiplying into our box, this would be 2x to the third. This would be 2x squared. This is minus 2x squared. This is minus 2x, or negative 2x, I should say. This is 12x, and this is 12. Again, I'm just following the rule where I'm multiplying my coefficients together and adding my exponents. And you can check. If your diagonals are not like terms, that means you probably forgot the most. It's easy to forget a variable somewhere. So always check. Here, everything looks good. The first term in my box is this 2x to the third. 2x to the third. These two cancel each other out because it's a positive and a negative, so it goes to 0, so you don't have to write that. This will be 12x minus 2x. That's a positive 10x. And that's plus 12. So for the last example, I'm going to kind of say, if you feel like you can do it on your own again. Otherwise, follow along. You can do this two ways. Now that this parenthesis is in front that has 3 terms, we could have a box that is 3 columns and 2 rows. Or having the same thing, if it was tipped upward like we have been doing, will give us the same thing. But I just like to always put my first parentheses on the top of my box. So I have to kind of tip my box over. So I put on each, above each column, 3x squared, a plus 1x, a plus 1. I have an x and a minus 2. Multiplying into the box is 3x to the third, 1x squared, 1x, negative 6x squared, negative 2x, and then negative 2. So now our diagonals are just tipped over. Right, we have our x squared diagonal and our x diagonal. We have our leading term in the front, our caboose in the back. So I'd write this out. My final answer, 3x to the third. This would be a minus 5x squared, and then minus 1x minus 2. This is a 4-term polynomial. We call it a quartic. It's degree 3 with a leading coefficient of 3. And I think that's all I want to do. 1 second. I'll pause my recording and then tell you I have some homework instructions to figure out where it went. Toot, 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 toot. Why does it let me pause? Usually I have a pause button somewhere. Pause. So instructions for the homework, there's just two small things. For number 6 on the homework, it's going to ask you to find the area. So to find the area of a rectangle, you take the length times the width. So you could use the box method to find the area of a rectangle if you're given, like if your length is given to you as a polynomial and your width is given to you as a polynomial too, you can use your box method. Number 10, you're going to skip entirely. And then there's problems on the back, but the back side, save for Monday. That'll be your kind of practice assignment for Monday. Oh, cool. Well,